In this precalculus algebra video, we're going to study what are called piecewise defined functions. So a piecewise defined function is one that's defined in pieces. So this is an example. We have a function f of x equals, okay, it's 2 minus x, but that applies for only when x is less than negative 1. And the function is 2, and that applies for when x is greater than or equal to negative 1. So the way I like to handle these, we're going to graph this. The way I like to graph them is by graphing the pieces in their entirety and then applying the restrictions. So for example, this first part, f of x equals 2 minus x. Well, that's just a line y equals 2 minus x. So we're going to graph the line, this line dotted, and then apply a restriction. So this line goes through the point x equals 2, and then when x equals 0, y equals 2. So it goes through these 2 points, right? And it also goes through the point, like when x is negative 2, it goes through the point negative 2, 4. So I'm plotting 3 points so I can graph the line. So it goes through this point, that point, and that point. Let's draw the line through those points and dotted. Okay, so here it is. It's all dotted, like so. Okay, and then we go back to our original problem, and it says, well, you want that line, but only when x is less than negative 1. Okay, x is less than negative 1 here, which means you don't want this part of the line. Okay, you only want that part of the line because that's the only part for when x is less than negative 1. So let's get rid of this part right there. So there it goes. There go those points. Okay, and then from negative 1 onward, right, that is from here onward, we're going to darken the part of the line we want. So let's darken that, like so. Okay, now, so this is the part of the graph we want, right? That's this part. There's one issue, and it's that this only applies for when x is strictly less than negative 1, which means that you don't want this part of the line that happens right at negative 1. To indicate that you don't want this point right here, we draw an open circle like so, and that implies that that point is not on the graph. That is, when x is negative 1, the y-coordinate is not this right here. It's not the y-coordinate of the point on that line due to the line. Okay, now we go on to the second part of the graph, which applies for when x is greater than or equal to negative 1. And it says that when that's true, the function is equal to 2. So 2 is simply a horizontal line through y equals 2. And that applies for when x is greater than or equal to negative 1. So we come up here at negative 1, and we draw a horizontal line through 2, like that. Okay? And it extends infinitely far to the right. And this is solid right here. So in other words, when x is negative 1, we get the value 2. And I know that because this says x is greater than or equal to negative 1. And that tells me this rule applies, y is 2 when x is equal to negative 1. Okay, so you can clearly see from the graph that this function has 2 pieces, right? So sometimes they have more than that. Let's give an example of a function that has 3 pieces, piecewise defined with 3 pieces. So here are the 3 pieces, right? The function is negative x squared, and that applies for when x is less than or equal to 1, x squared between 1 and 2, and x minus 3 for x greater than 2. So I like to graph the pieces in their entirety and then worry about the restrictions. So first of all, y equals negative x squared. That's a downward opening parabola. And let's graph it through a few points. So when x is negative 2, y is negative 4, right, for this rule right here. When x is negative 1, y is negative 1. When x is 0, y is 0. When x is 1, y is negative 1. And when x is 2, y is negative 4. So now I'm going to draw in the graph dotted, just like before. So I'm not worrying about restrictions at this stage. Just drawing it in. Okay, and that's the graph of negative x squared. But where do we want that? Well, we only want it for when x is less than or equal to 1. Well, here's 1, which means that we only want this part of the graph, because that's the only part that applies for when x is less than or equal to 1. That is, we don't want this branch of the hyperbola or the parabola we just graphed. So let's get rid of it. So there go all those points. Okay? And then we want to get rid of this point too, right there. Okay, and then we're going to go ahead and darken this part because we do want this part of the parabola. So let's go ahead and make that dark now. So there it is, and it extends infinitely far in this direction. And then you have to ask yourself, what happens at this little point right here? And the answer is we want to keep it solid because this rule applies for when x is less than or equal to 1. So we definitely want to include that point right there. We don't want to make an open circle. And then we go on to the next part of the graph, and it says that the next branch is x squared, and that applies between 1 and 2. So just like before, we don't worry about the restriction. We just go ahead and graph x squared dotted. That's going to go through negative 2, 4. So right there, negative 1, 1, 0, 0, 1, 1, 2, 4. And then here's the dotted parabola. Like so. And the question is, which part of the graph do we want? And the answer is only between 1 and 2. So we only want the branch of the parabola between 1 and 2. So we're going to get rid of all those points. Okay, let's go ahead and do that now. So I only kept the part of the parabola between 1 and 2, and now we want to darken that part, darken that branch, like so. And then we have to ask ourselves, where does that apply? Well, when x is 1, we don't want that, right? Because it's x is greater than 1, which means when x is 1, we have to put an open circle right here. So this branch does not apply when x is equal to 1, but it does apply when x is equal to 2. So we want to keep this part solid right here. So that should actually be down maybe a little bit, because when x is 2, y is 4. So, but we do want to keep a solid point right there, right? When x is 2, the point is on this branch of the parabola. And then we go on to the third branch, or the third part of our function, and it's the line y is equal to x minus 3. And that goes through the point, let's see, when x is 3, y is 0, so it goes through this point right here. And it goes through the point when x is 0, y is negative 3, so right there. So I want to graph the line through those 2 points. Let's do that. It's going to look like this. Okay, and then we ask ourselves, of this furthest line, which part of it do we want? And the answer is only when x is greater than 2. So we only want this part of the line, right? Because x is greater than 2. We don't want this part, so we get rid of that part. Let's do that now. There they go. Okay, and then from 2 onwards, we want to darken that part of the line. Now, when x is 2, you plug in 2 and, well, okay, you have to be kind of careful because when you plug in 2 into this line, you get negative 1. So the line goes through 2, negative 1. And let me ask you, should I have a closed circle or an open circle right there? Open, because x is not equal to 2. Or when x is 2, this rule doesn't apply. The other rule applies, okay? So we want an open circle at 2 for this line. So an open circle like that, and then we want to graph the rest of that line. Let's do that. Okay, and this is the third branch. Open circle at 2 because it doesn't apply at 2, and then from 2 onwards we get the line. Okay, so you can see that this piecewise defined function has 3 parts, right? First branch, second branch, and third branch, and what happens at the endpoints you have to pay extra attention to because it can be a little bit subtle, as this example illustrated. All right, until next time.